A particle moves along the x-axis according to x of t equals 10t minus 2t squared. What is the instantaneous velocity at t equals 2 seconds and t equals 3 seconds? What is the instantaneous speed at those times? And what is the average velocity between t equals 2 seconds and t equals 3 seconds? In this problem, we are given the position function. The derivative of a position function is the velocity function. So the first step in this problem is to take the derivative of 10t minus 2t squared. This derivative is 10 minus 4t. After we take the derivative, we can plug in our first time 2 seconds. The velocity at 2 seconds ends up being 2 meters per second. We can then repeat those steps at t equals 3 seconds, which then yields a velocity of negative 2 meters per second. For part B of the problem, we are trying to find the speed at those times. Speed is equal to the absolute value of velocity. So we can take our previous answer and take the absolute value of it at t equals 2 seconds to get the speed at 2 seconds equals 2 meters per second. We can then do the same thing for t equals 3 seconds. Taking the absolute value of negative 2 meters per second gives us 2 meters per second. Part C wants us to find the average velocity between 2 seconds and 3 seconds. To do this, take the velocity at 2 seconds plus the velocity at 3 seconds and then divide by 2. This will result in 0 meters per second divided by 2, which is 0 meters per second. Therefore, the average velocity from t equals 2 seconds to t equals 3 seconds is 0 meters per second.